Hello everyone, this is H Academy. Today we will solve M1 January 2026 question number 4. This question is about moments. So now let's solve it. So first let's read the question. Figure 2 shows a uniform rod AB length 6 meters suspended by two light vertical ropes. The first rope is attached to the rod at A. The second rope is attached to rod at C, where C equal to 0.4 meter. The rod has a mass 30 kg. A particle of mass 20 kg is now attached to the rod at B. The rod is in equilibrium horizontal position. Find the tension in the rope attached to the rod at C. So they have told us to find the tension that is attached to rod at C. They told us to find this tension, which is TC. So before finding the moments, we have to solve the diagram. This is TA, and they have given us the rod has a mass 30 kg, so 30 kg will be here, and there is a particle which is a mass 20 kg is attached to rod at B. This is 20 kg, and now we have to find this distance also. How to find this distance? Here is 6 and here is 0.4. If we minus 6 minus 0.4, we'll get this distance, which is 5.6. Is it 5.6? Yes, it is 5.6 meter. Okay, now you have to take moments here. Before taking moments, I have to tell that this is part 1. The formula of moments is moments equals to force into distance, and this distance is perpendicular distance from the pivot. Let me write it. Okay, so this distance is perpendicular distance from the pivot. Now another formula is we take moments like this. Clockwise moments, let me write the full form. Clockwise moment equals to anti-clockwise moment. So here I'll do is they have told us to find the tension at rod at C. Now I'll take moments at A. So let's take moments at A. So if I take moments at A, I'll end up getting the T at C, which is I needed. So if I take moments at A, I get is T into 5 to take moments. We'll take moments at A. If we take moments at A, we cannot take moment A. We have to take from here. So now we will take all the clockwise moment here first. So if we see the what are the clockwise moments are, here you can see this is the clockwise moment, which is 30g into 3, one clockwise moment, and another clockwise moment is 20g into 6. So we take it as 30g into 3 plus 20g into 6. This is the clockwise moment. And now anti-clockwise moment. We have taken moments at A here, so this will not be counted. We'll count this one. So TC into 5.6. If we subtract and solve it, we get it is here is 210g equals to 5.6 TC. So if we solve the TC here, we get is 37.5 G. If you multiply by G, we multiply G here, we multiply with g, we'll get as 367.5. if we round it up to 1 dp or 1 3, here is 4 sf, we'll write in 1 sf, so you can write 368. so this is the part a, one number part. So now we have to find the part 2. They said find the tension in the rope attached to the rod 8a. so this looks more easier because here is TA and here is TC, and we have two masses here. If you all add up together, you can get that too. So in part 2, TA plus TC equals to 30G plus 20G. So here you got TC is 37.5 G, and if you add together it gives 50G. if you subtract TA here, 37.5, we get here is 12.5 G. if you calculate G here, we get TA will be, which is 122.5. here is 3 SF, so you have to write the answer in 4 SF, sorry, here is 4 SF, we have to write the answer in 3 SF. so if you write in 3 SF, we get 123 Newton. This will be Newton 2. so this is the part 1, part A 1 and 2 done. Now let's move to part B. In part B says the particle of mass 20 kg at B is removed and replaced by a particle of mass m kg. This is unknown. The rod remains in equilibrium horizontal position. Find the exact maximum value of m. So what they have told us, find the maximum. So what the maximum means? It means maximum means point of tilting. Point of tilting now, because when we put a maximum force here, this pivot will start tilting like this. It's like this here. If you put a maximum m, this will tilt like this. This will tilt like this. It will not remain horizontal anymore. So I hope you understood. So now let's remove this force 20 G. Let's remove the 20 G force now right here, which is mg. So we wrote mg here, which is capital M. Now the rod will tilt. So let's solve the part B. Let's solve the part B here. So if this is tilt, it will tilt with C. So here the tension at A will be 0. So you cannot consider TA anymore. We have to, it will tilt with C. It means it is like this way. It's now like, it's like this now. It will be like that. So it will tilt with rod C, point C. So you have to take moments at C. If it's tilt at C, we have to take moments at C. B, so we take moments at C. If you take moments at C, I can clearly see that mg into 0.4, which is a clockwise moment. Mg into 0.4, which is a clockwise moment, and anti-clockwise. The formula is clockwise equals to anti-clockwise. So another moment which will be anti-clockwise. It is 30 g. It will be 30 g, and we need this distance. We need this distance. If we subtract, here is 3 and here is 0.4. So if we minus 3 minus 0.4, we get is 2.6. So it will be the anti-clockwise moment will be 30 g into 2.6. 30 g into 2.6. So it will be mg into 0.4. There is 2.6, which is 78g. If we cancel the m, so 0.4 m equals to 78 divided by 0.4, which is the m is 195 kg. So this is the part B done. Okay, so this is the question number 4 from January 2026 moments. We have solved all the parts here. Here you can see. So this is the answer.